Hello, it's Kurt Soderberg. I am presenting my assignment 2, Determining Significance, for my EDAD865 class. The population here is the Middle Border Conference, which is our conference that St. Croix Central is in. Consists of 8 schools total in the northwest area of Wisconsin. But because St. Croix Central is my sample, I will take them out. So we'll actually use 7 scores. And we're going to be looking at the ACT mean scores for the class of 2020. So framing the information for me, the population for the Middle Border Conference mean ACT is 20.8. I do not know the standard deviation of the population, so that will um, uh, require me to use a T test or T distribution, which I'll demonstrate here in a moment. Sample information, if from St. Croix Central, we have 97 SEC students with the mean ACT score of 21.07 and then a standard deviation of 4.46. Some of the information more detailed. The hypothesis is that the null hypothesis is that the mean of the Middle Border Conference will be equal to uh, the sample mean of St. Croix Central. The alternative hypothesis is that the mean of the Middle Border Conference will not be equal to the mean of the sample St. Croix Central. It'll be a two-tailed test because the scores could fall above or below, significance be above or below. And as I mentioned, the we do not know certain information, so we'll use the t distribution. Uh, at a significance level, I chose a 0.05, and that means that 95% of the scores would fall inside, would expect to fall inside of the acceptable range. For degrees of freedom, there's 97 students in our sample, so the degrees of freedom is determined by taking your samples minus 1 or 96. And so for me, I use the degrees of freedom of 120 from the chart in the text. So the critical value that I've determined T is, we're looking at, is the T value going to be greater than 1.980. If it is, we would reject the null hypothesis. If the value is less than negative 1.980, we would reject the hypothesis. So critical value is 1.980, and I'll demonstrate that on my chart that I created. So first we need to calculate the standard error, and that is taken by dividing the square root of the sample size. The standard deviation divided by the square root of the sample size. So again, ours was 4.46 standard deviation at St. Croix Central, and the population was 97. So you can see the math there. We come up with a standard error of 0.45. Then the t-value calculated to be sample mean minus population mean divided by the standard error. So we have our sample mean of St. Croix Central, 21.07, population mean 20.8 from the Middle Border Conference, and divided by our standard error that's calculated above at 0.45. And you can see that our t value is 0.6. And then we'll judge that based on the critical value, and we'll make a determination. So here's the chart that I created, and I'll just run through it quick. First, this is the Middle Border Conference mean, or some call it the mean of the hypothesis, the null hypothesis, 20.8. Here I show two things: a critical value in green, and that's basically the border of anything outside of that. Those two portions of the curve would be considered in the rejection area, right here and here. So if that t-value falls outside there, then we would reject the null hypothesis. So I put in our t-value as 0.6, and you can see where that falls. It's it's 6.6, and with one standard deviation, so it's 60% of the way to one standard deviation away. So it clearly falls inside of that. It does not fall outside in the rejection area. So the conclusion that we would come to is that we would fail to reject the null hypothesis. So Middle Border and SEC scores are statistically equal. Some of the assignment questions I just wanted to make sure I address. So you asked us to explain what significance means with regard to the data. Here are some bullet points that I came up with. The results are not attributed to chance. So we would say because it fell inside that significance area, um, that we fail to reject the null hypothesis, that we would say that it's did not occur due to chance. The null hypothesis is true or not rejected, which means there's really no difference. There's a low probability of getting a result outside the critical value. And then how the reminder is that one of the things that I've learned in this particular section about null hypothesis and t-values and so on is that it's nothing's 100% definitive in statistics. It's about probability. So we're simply saying that probability is that number is not due to chance. Then number two, determine the experimental group shows a significant difference from this control. The experimental or sample group does not differ statistically from the control group. That's what we've shown here. And then number three, describe what potential program changes you may recommend based on your analysis of the data, if any. Nothing outside of our normal ACT prep procedures. We're always trying to fix things and do better with whatever our procedures are, and identifying individual needs of students and moving that forward. We've in the last year we added our pre-ACT, and we're also we added Aspire interim assessments starting last year. Now we'll add an additional one this year, so our students will take 2 interim assessments for the Aspire and then the actual Aspire in the spring. So that will give us 6 data points by the time they enter their junior year, and 7 data points by the time they take their ACT. So we should have a pretty good idea of what's happening with those students. And that's my presentation. Thank you very much. I look forward to your feedback.